Cloud computing is a general term for hosted services that are being provided by distributed systems, various service providers out there. And allows companies to use computing resources like they do water, power, gas, anything of that nature. It's become a real commodity. And so you can use cloud resources on demand. As you need it, you can spin up new servers. When you don't need those anymore, you can spin them down and delete them and not have to pay for them anymore. The notion of cloud computing isn't really new. It's been around since mainframe technologies from over half a century ago, where you had a mainframe was using all these dummy terminals out there. These are just interfaces into the mainframe itself. And what it allowed was very cheap endpoints out there when all the resources, all the processing power was stored in a central point. Similar case is occurring with cloud computing. You have all these standard terminals, if you will, all our laptops, our desktops, that sort of thing. All the computing power, all the resources, the storage, the memory, processing power are all centralized in a cloud computing platform. May not be a single machine like it was in the mainframes of the 50s and 60s. It might be a server farm, several servers, but it's all appearing as one common platform. There are a lot of advantages to this. From the standpoint of as you need things, you can generate them. You can provision a web server to work for 2 weeks and then tear it down because you don't need it anymore. Generally, this satisfies the on-demand nature of computing. Look, I need a project server for the next 6 months, but I don't want to go out and buy a $4,000 server to do that. I can just get an on-demand server through some cloud provider and use that for the next 6 months. Elasticity, the idea that we can grow and shrink resources as needed and only pay for what we need as we need it. So we don't need to go out and have huge upfront costs to kick something off. What we end up with is the ability to go and provision services and pay for them by the minute, by the hour, pay for the bandwidth that we use, and we end up with much lower upfront costs to give us the computing power that we need. If you look at, kind of equate this to agile development, as you need something, you create it. You spin up a server to do a test or ops check something. You do the test, it's complete, you can spin it down, and you don't need it anymore. Agile startups work the same way. As you're refining your business process, you test something, you use it, you find that it works, great, go with it. Find that it doesn't work, you can delete it, start over, and keep going. But it's this idea that you're paying for what you're using. You don't have unused resources sitting around anywhere, and you can grow or shrink as the demand that you need occurs. There are a lot of advantages to this, mostly around cost and resource effectiveness. Again, I don't have a bunch of equipment sitting around taking up space, chewing up power, HVAC support requirements. I don't have any of that now. I can outsource all of that to a cloud provider, and then I can grow and shrink that need based on what's actually happening in my business. There are primarily three different cloud computing types, service types out there. Infrastructure as a service, where you're creating router switch networks and having that grow and shrink as you need it. Platform as a service, this is things like Rackspace and the Amazon EC2 instances. These are actual servers or specific application servers that you can spin up as you need it, when you need it, based on the computing power that you need. And then finally, there's software as a service, and this is the idea that I don't have to have shrink-wrapped installed software on my systems that are there. I can just go to a web page and use the service through a web page. And that can also be on demand as well. When I'm done with it, I just stop my subscription to it, and I haven't shelled out, say, $4,000 for a license per user. I've just paid on a monthly basis for what I actually need. There are a couple different kinds of cloud implementations. We'll talk about each of these: public clouds, private clouds, hybrid clouds, and community clouds. For private clouds, there are on-prem clouds, on-premises clouds, and then externally hosted clouds. From an on-premises private cloud, you see some large enterprises adopting this where they've got a cloud, but it's hosted internally. The servers are owned and operated by the organization. They're hosted by the organization. They're in a data center owned by the organization. And all of the maintenance, security, operational aspects of that are owned by the organization. What this means is that, yes, you have the cost of all that, but you also have the benefit of being able to have direct access to everything. So you control physical security, you control network security related to it, and you have the ability to have visibility into everything that you're running through that private cloud. Now, there are physical solutions to this where you buy physical servers and do one server for each application or user that you might have, or you can virtualize this using VMware infrastructure or Zen or something like that, where you can buy very large power servers and then slice it up, divvy that computing power out to your users as they need it. So this would be the equivalent of operating a mini rack space or a mini EC2 inside a company. Externally hosted private clouds. This is the same concept, except we've taken the operations, the servers themselves, the heating and air conditioning requirements, the power requirements, and transferred all of that to a third party. So we could probably do this in a third-party data center somewhere where we get a couple racks of equipment space, we put our servers in there, and we run our cloud from that third-party data center. That's one way of doing it. The other way is that there are third parties out there which will do all that for you. They'll buy the servers, they'll provision the servers for you, and they'll make it available. What makes this interesting is this is private. It's just for your organization. You're not going to be on a shared server with anybody else. So in theory, you have a little bit more control over what goes on with those servers, but again, they're not physically controlled by you, and you may even not have administrative access to the backplane on them. So from a security standpoint, you might have less control of it than you actually, if you had actually had the devices inside your premises. Essentially this comes down to a big, gigantic virtual LAN or VLAN in some type of hosted environment. And there are various examples of this with Amazon VPC or VMware vCloud Air that you can get. Public clouds are most commonly equated, again, with rack space or Amazon EC2 or even the big service providers like webmail providers through Gmail. Office 365 is a good example of one. Google Docs has their copy of public cloud implementations or services available in the public cloud. All of these are accessible remotely. The downside to using this is primarily from a security standpoint. As a user of it, you have no visibility into the server itself, what's running on that server, who's accessing that sort of stuff on the server. Now, some applications try to go the extra mile here and tell you, give you some visibility into the aspects of security with regards to your data. Sites like Box will tell you who's accessing your files, when they accessed it, who modified files. So you can get some level of security, but it's usually application by application dependent, public cloud provider by provider basis. It's very dependent on the implementation of that. And this will all be spelled out in the service level agreement. So one of the challenges of cloud computing is figuring out which model, public, private, hybrid, or community, is going to provide you with what you need from a data availability perspective and from a security perspective, plus a host of other business requirements that you might have. From a community cloud perspective, these are clouds that are provisioned to serve a particular group or a community. Like the U.S. government has a federal cloud that is shared between all different federal agencies. You may or may not have access to that. They are owned, managed, and operated by typically by a third party, but it may be actually members of the community that are operating it as well. The downside to this is that you're operating in a shared environment. So you need to be cognizant of the fact that you're not the only one using this server, and there are 20 other servers next to you being used by all different people. So if you're, those transit paths coming in and out of that network, those pipes, are all being shared. And so because of that shared nature, you can face a common set of attackers. So one attacker coming after a site on server number 20 doing a denial of service attack, well, that's going to affect you even though you're on a totally separate server because that bandwidth is all shared. A hybrid cloud. Take any combination of the three previous clouds that we talked about, public, private, or community, and merge them. So you can have private community clouds, you can have public community clouds, and essentially what you end up with is a hybrid cloud, or a combination of two of the different cloud types. There are advantages and disadvantages to doing this. Generally, you inherit the advantages of both, and you also inherit the disadvantages of both. And again, the primary disadvantage of a hybrid is that you're dealing with shared usage usually. And so you need to be cognizant of the fact that you're not the only one using that particular server. There are other people using it.